Alright, so summative number 8, the first couple sections are going to be a second attempt for you guys. The first of which is graphing quadratic functions. So we're going to be looking at quadratic functions in two different forms, and you don't actually have to execute the graph this time. I just need you to understand the different attributes of the quadratic function. So these first two are in what we call vertex form. There we go. So the vertex form, thusly called vertex form because you should be able to identify the vertex from vertex form. So remember, vertex form is y equals a and then x minus h quantity squared plus k, where the vertex is your h comma k, and there's a negative sign built into the x minus h part, so you always have to think opposites. So this guy is going to have a vertex at -4 and then -5. Now the axis of symmetry is the line that cuts through your parabola. So it's always x equals whatever the h value was. So for us, that would be x equals -4. Last time some of you lost some points because you didn't write the axis of symmetry as a line. So make sure you're writing x equals and then whatever that the h value of your vertex is. Transformations, I'm looking for things like right, left, up, down. So this one would have been shifted, and this time you could graph it if you're not sure, but it's definitely shifted left 4, and then down 5. And you might want to graph it if I ask you for domain and range on your graphing calculator. So you would just type it into y1, but this is a parabola who's been shifted left 4 and down 5, so now I don't know exactly what it looks like, but something like this. So the domain for parabolas is always -infinity to +infinity. The range, however, starts at the, in this case it starts down here where it was shifted down 5. So your range starts at -5 and then goes up to infinity. Remember, domain and range have to be least to greatest for interval notation. And I will consider it a concept error if you don't do domain and range intervals properly. Alright, number 3 and 4 are both in standard form, so in order to find the axis of symmetry, you can look at your table and look for symmetry to find the vertex, or you can just calculate it using -b over 2 times a. Just make sure that 2 times a is either being done in your head or using parentheses on the calculator. So for us, the opposite of b would be, so x equals +8 divided by 2 times the a value. So right here, 2 times 2 would be 4. So 8 divided by 4 is going to come out to a 2. So your axis of symmetry, kind of wrote all over the place here, is x equals 2. Boom. Make sure it's written as a line in the form x equals. So what that means for us is that the x value of the vertex is also 2. And then to find the y value, you have a couple of choices. You can either manually plug in x equals 2 to the function, or you could just, if you're going to graph it, you might as well just use your table to figure it out. And remember, we're looking for symmetry on your table. So you don't actually have to plug anything in. If you plugged in x equals 2 here and here and here, you're going to get the same answer as the calculator. And it looks like our vertex is at 2, -7. But on your table, what I'm going to be looking for is, as you scroll through the table, you should see symmetry surrounding 2, -7, for instance. Right above it is the point x equals 1, oh gosh, I should be able to do this. 2 minus 8, -6 plus 1, -5. And then down here at 3, it would also be -5. So that's what a lot of kids do when it comes to finding the vertex. They've kind of stumbled upon the little trick of looking for the symmetry in the table, and then you know the vertex is the number that's right in the middle of those symmetrical points. Alright, so practice those however you need to do the questions. I know some of you don't have graphing calculators, so remember you have that emulator you can try on your phone or on a non-Apple product. So for this one, we do need a graphing calculator. Well, we don't have to use one, but it sure is nice. I'm going to program this into y1, and then I'm going to use x's instead of t's, and I'm going to use that to fill out my table. So on my calculator, I just shut down my computer, so I bet it's not there anymore. Let's find out. Maybe. Alright, 4 years later. There we go. Close. Meh. Nope, not there. Alright, so it was -16, and you have to use x. So x squared plus 195x, and then plus 4. They wanted you to fill out the table, so you'd go to second graph, which is the automatically filled in table, and then copy the data points for 2 seconds, 3 seconds, and 4 seconds. So I'm going to copy down 330, 445, and 528. Alright, so this was 330, and that was 445, and that was 530, or sorry, 528, excuse me. I think. I don't know. If it was wrong, I apologize. Alright, so, you know what? I don't feel comfortable with that answer. I need to go back and look. 528, yeah, alright. So now it's going to ask you to calculate the average rate of change. You need to know what that means. So average rate of change means the slope between 2 seconds and 4 seconds. So find your data for 2 seconds and find your data for 4 seconds. And slope means the change in the height, so the y values, divided by the change in the time, which is the x values. But that's what slope means, right? So I just subtract them. I just make sure I stay in the same order. So 330 minus 528 divided by, and then our time goes from 2 seconds to 4 seconds. So maintaining that same order. If you're going to use your calculator and do this in one step, just make sure you put parentheses around your numerator and your denominator. But notice the height is going upwards in time, so you should get a positive answer of positive 99 feet per second, looks like on my calculator. Alright, I'm sure there's another question like that somewhere on your review. Please practice those, guys. Let's look at number 7. So this is the question where you have to program your calculator into y1 again, but remember we're using x's instead of t's. And they want to know when the ball reaches the maximum height or what the height is. So this is where you're going to use the maximum. And then it also wants to know when it hits the ground. So when it hits the ground, remember to use the command for 0. And you have that little yellow card that you can use on a test to help you out. So first things first, get your programming done in your calculator. Remember, your calculator overtypes. So if that's annoying to you, you might want to just retype the whole function in again. This is 57t. So I'm going to type 57x, and then I'm going to delete that last digit. And then plus 3.5. Oops, no. No, we're looking at the wrong function. Oh, goodness. Back up. Alright, 48t. And then plus 7. Okay, so your card says after you program your y equals, go to your window and adjust it accordingly. So remember, x is time. It would be weird to start time at negative 10 seconds. Let's start it at 0. And I think we're throwing a ball in the air, so I'm pretty sure 10 seconds is totally fine. Now, I am throwing a ball in the air, and I do want to know when it hits the ground. So later on, they're going to tell you on the yellow card to make sure y minimum is at negative 10, just so you can see below ground a little bit. Pretty sure I can throw higher than 10 feet in the air, though, so let's go like 50, just to be safe. And hit graph. Well, it's not a great window. Apparently 10 seconds was way too long. I'm going to pull that back a little bit. Let's not go 10 seconds. Let's go like 7 seconds. That was a little ambitious. Even that's ambitious. Whatever. Alright, so first question. Find what the maximum height was at what time did it occur. So we're going to go to second trace. We choose maximum. And then when it says left bound, what I need you to do is figure out a time before it hit its maximum height. So this is the maximum, and it occurs like between 1 second and 2 seconds. So a time before it reached the maximum, I'm going to go with 1 second. And you guys are welcome to scroll, but this hopping thing's kind of neat. And then I need a time after it reached the peak, so I'm going to go with 2 seconds. And then guess, I just hit enter, you don't have to do anything. And what I do need you to do, however, is recognize that x is time and y is height. Because if you write the reverse of that, it's goofy. So this is going to round to 1.50, comma 43. So I'm going to go to fill in the maximum height. That was a height of 43 feet at 1.50 seconds. So then a follow-up question is, when does the ball hit the ground? Whoopsies. And we're going to be using the zero finder from that calc menu, except... you know, I can estimate it. It's like 3 point something, clearly. But I need a better answer than that. So, zero finder. And it's going to ask you those same questions. So when it says left bound, it wants a time before it hit the ground. And actually, we're already at a time before it hit the ground. So I'm going to hit enter. And then give me a time after it hit the ground. Well, if it hits the ground like right after 3 seconds, let's go 4 seconds. That'd be after. And then enter one more time for guess. And it should give you something that, and I'm going to ask you really specifically where to round to. I think I told you the 100th on the test, so whatever I say on the test, just follow those instructions. So here, just to be safe, let's give 3 decimal points. So 3.139, I'd round that to. Whoops, 3.139. All right. 3.139. So whatever the instructions will say, it'll be really clear on the test. I've made a big deal about that this time. All right, so yes, please, please, please use your yellow card and practice those. Oh, here's a new topic, solving by factoring. So the first task is, can you factor? And the answer better be yes. And then you're going to set your factors equal to 0 and solve. So I'm going to skip to number 10 here because it's a little more challenging to factor this one. The first terms have to multiply to 2x squared, so we'll use 2x and x. And then your last terms have to multiply to -5. But you're going to want your arches to add up to +3. So this is the puzzle thing where you have to kind of play around with the order. What if you tried a +5 right here and a -1 right here? Because the arches here would add up to 5 minus 2, which would be a 3. Now, unfortunately, your hard factoring is not the end of the problem. You still have to solve it. So you're going to take each of your factors and you're going to set them equal to 0. So 2x plus 5 could be 0, but also x minus 1 could be 0. And then you have to take the extra step to solve these. So like on this one, you're going to subtract 5 and then divide by 2, so you get x equals -5/2. And then on this one, you're just going to add the 1 over. So you often will get 2 different answers. They're independent from one another, but they're both correct. Please don't skip this step. This step right here, going from factor to set factor equal to 0 and then solving it. I get a lot of kids who have this weird concept of take the opposite, and then they get in big trouble on this question because they don't understand what you're doing. So make sure you're solving the factor. All right, number 11 is the next one I'm going to do. Factoring number 11, I notice it's that square rooting pattern question. So you're supposed to take the square root of each term, and then one's a plus and one's a minus. That's the good twin, evil twin pattern. So 10x, and then plus 7 and minus 7. Wow, I could not have written that any sloppier, could I? Let's try that again. All right, so 10x, I don't know if that's better, plus 7 and 10x minus 7. So again, you need to set your factors equal to 0. So I'm going to do that under here, I guess. 10x plus 7 equals 0. And then also this factor. So 10x minus 7 equals 0. And after you solve, these are like little linear equations. Now you're going to subtract the 7 and divide by 10. You can show the work and do that in 2 steps if you want. Here you're going to add the 7 and divide by 10. And expect to see clean fraction answers, please. All right, let's take a look at number 13. Number 13 is, again, a factoring question, and I kind of gave you a skeleton here to remind you that the kind of factor I'm looking for is for you to take the common factor out. So there's a common factor of 2x you should take out of there, and when you divide these both by 2x, you still have x plus 4. So what confuses kids sometimes is they don't recognize that 2x is a factor and x plus 4 is a separate factor. So you have to set each of these equal to 0, and you still are trying to solve them separately. So like here, you're going to divide by 2, but guys, don't get tricked. 0 divided by 2 is still 0. And then here, of course, you're going to subtract 4. So x equals -4. So you're getting 2 answers on all these questions so far. It's not always 2 answers, and we'll see a case coming up, I think, next, where we get the same answer twice. So this one looks really tricky at first, but I'm going to settle with 4x and 4x for my 16. And I'm going to use -3 and -3 for 9. And check that the arches add up. So this is -12, and that's another -12. So yeah, that's going to add up to -24. So commit to factoring before you try solving your factors, but notice these are the same factors. So when you set this factor equal to 0, it's the same solution you're getting both times. So that's why there's only one blank here. So you're going to add the 3 over and divide by 4, and you're going to get x equals 3/4. So please don't be afraid to show extra steps when you're solving by factoring. Sometimes kids get stuck in the minutia of the problem. Some of the steps that your math teacher does in her head really quickly, maybe you guys aren't ready for that, and that's okay. I've been doing this a long time, All right, so we're going to be solving by square rooting. You might want to have your purple chart out for your perfect squares list, or else you can write them at the top of your paper. 4, 9, 16, 25, 36, 6 squared, 7 squared, 49, 8 squared, 64, 9 squared, 10 squared. All right, there's more, but we can stop the list there. All right, so your first step is to isolate whatever's being squared, and then you're going to square root both sides. So when you square both sides here, you get x equals. Don't forget that the answer is not just positive, but also negative, so you can shorthand that by saying plus and minus. But then you've got to simplify. So 72, the biggest perfect square that divides into 72 is actually 36. So we'll reduce this to 36 times 2, and then you have a better name for 36, guys. Square root of 36 is really a 6. So it's 6 square roots of 2. So positive 6 square roots of 2 and also negative 6 square roots of 2. Make sure you have two answers there. The plus and minus is the short way to write it, but you are welcome to write x equals 6 square roots of 2 and x equals negative 6 square roots of 2. Totally fine. All right, I'm skipping to number 19. We are not isolated yet. I don't want to square root quite yet. Let's divide by 2 first. So you get x squared equals 24, and now it looks a lot like number 17. So we're going to square root both sides. And then I notice 24 is not a perfect square. However, I think we can reduce it. So 24 has a perfect square factor, doesn't it? Wasn't 4 going to divide into that? So it's square root of 4 times square root of 6. But you have a better name for the square root of 4. That's a 2. Alright. Again, you can separate the answers if you want. I have the answer key that I'm sure I'll post, and it has all the answers if you're doing the in-between problems. I'm just running out of time here. I don't want to make this video 48 minutes long. Alright, number 21. Isolate, isolate, isolate. Let's subtract 1 first. So you have 2x squared equals 26, and we're not quite isolated yet. I want you to divide both sides by 2. Alright, so you have x squared equals 13. Now you can square root both sides. And this is a case where the radical is not going to reduce at all. So don't get tricked and just put square root of 13 and walk away. Remember, it's both positive square root of 13 and negative square root of 13. So there will be cases where when you get to the radical step, there isn't any simplification, and that's all right. All right, number 23 next. We're going to need to isolate. Now the worst thing you can tell me is to distribute the 4, because you can't. Not the way it looks right now. Instead, let's divide by 4. Now it's out of there, and you have the quantity x minus 2 squared equals 5. Now it would be a great time to square root both sides of your equation. So square root and square will cancel each other, but you still have x minus 2. And then because this is the moment that you square rooted your solutions now become both positive and negative square roots of 5. So then your final step, which kind of looks awkward in the math because you're just adding the 2 over to this side, since I can't combine the 2 with the square root of 5, what we're going to write down is 2, positive 2, and then we're going to simultaneously add and subtract the square root of 5. So that's a great way to write the answers. If you want to separate them, you can say 2 plus square root of 5 and 2 minus square root of 5. So either answer set, the way it looks is fine as long as you're equivalent to what you're supposed to have. All right, and this is another new one, guys, completing the square. So a couple of formulas you might want to think about here. How do you find c, which is like that blank that we're always looking for completing the square? You take your b term, you cut it in half, and then you square it. So for us, if we took this b term, which is 20, and we cut it in half, and then we squared it, that would be 10 squared, which is 100. So that's the value for c in this problem. Now when I take that and I want to write it in factored form, the way we factor it is we take whatever x is, and then we add half of the b term. That's why kids like completing the square so much, because you don't really have to know how to factor, you just have to know how to use the pattern. So for this question, it would be parenthesis x, and then I've done a lot of writing here, so I can't read it anymore. This b term, when you cut it in half, it's a positive 10. So it's x plus 10 quantity squared. So I'm just kind of asking you, do you understand where all these numbers are coming from for completing the square? I'm really trying to lead you into the next question for us, which will be number 27, which is, can you solve by completing the square? So first step, coefficients of 1, check. Next step, rewrite it so there's a blank, and you move the existing constant to the other side. So this 8 is going to get subtracted over, right? This guy is going to get moved over here. But if you add a blank to the left, you have to also add a blank to the right to keep everything balanced. So now in the blank is where we take that b, cut it in half, and then square it. So negative 5 squared is 25. So that's a 25, and that's a 25. Keep your equation balanced. So I think maybe we're to the point where we're realizing, why are we even doing that? Well, because this trinomial now is going to factor into this awesome formula of x plus half of b squared. Well, guys, half of b, half of this, is minus 5. Equals, and this is just an adding problem, right? Negative 8 plus 25 is 17. And what you've done is you've created a square rooting question for yourself. So now you can go ahead and take the square root of both sides. So you get x minus 5 equals square root of 17. Won't break down, but it is a positive and negative square root of 17. And then last step is to add 5 to both sides. Alright, completing the square is obviously the newest stuff for us, and maybe it's fresh in your mind and maybe it's confusing, but please do practice it. And be careful, guys. Woo! I didn't mean to do that. Error analysis question is what's going to come up on your test today. So error analysis means that I give you somebody else's work and they've messed up. So think about all the common mistakes. So here's what I've noticed. Common mistakes that I see are they forget to add the blank to both sides. Like they'll just do it to one side and not the other. So watch out for that. Another common mistake is the factoring step. They use the wrong sign. Like on that question we just got done with, they forget that it's half of the b term. So if your b term was already negative, that means the factor has to be negative as well. And then a common mistake, but kind of a general one, is they just flat out don't know how to find c. So they find the blank or c, whatever you want to call it, wrongly, incorrectly. I don't know what the correct word there is. Let's say incorrectly. There, my English teacher friends won't yell at me now. So those are all things to be looking for when you're analyzing someone else's work. And I'm telling you guys, the kid messed up. It's not like a matter of did he mess up or not. He did. Or she did. All right, good luck.